Hey guys, here we are on really going to wrap up our adding and subtracting of fractions here with some applications of fractions. So this is section 4K and it's going to be applications of fractions. We're going to be doing some order of operations problems, some solving equations problems, and then some word problems too. So our first one here is x plus 2/7 equals 1/2. So we want to remember that whenever we're solving equations, we're trying to isolate the variable, and we do that by doing opposite operations. And another name for opposite operations is inverse operations. So I'm just going to write inverse operations over here, just a reminder. And then our goal is to isolate the variable. Isolate just means get it all by itself. Okay. So when we have addition equations, then we're going to solve by the inverse operation or the opposite operation of subtraction. So we'll be subtracting. Alrighty, so just to highlight that, if we have an addition equation, we're going to want to subtract. All right, so I've got x plus 2/7 equals 1/2. I'm going to subtract 2/7 from both sides. And we know that if we're adding 2/7 and subtracting 2/7, then we've canceled that out, and all we have left over there is x, which is what we're going for. We just want that to be x all by itself on that side of the equal sign. We need a common denominator here, so I'm going to go with 14ths because I take my bigger number 7 and list the multiples of 7 until I find one that 2 will divide into. So the first multiple of 7 is 7, and that doesn't work because 2 doesn't divide evenly into 7. The second multiple of 7 is 14, and that works because both 7 and 14 can divide into 14. So to change this fraction, 2 times 7 is 14, so 1 times 7 is 7. And then this fraction, 7 times 2 is 14, so 2 times 2 is 4. And then I like to remind myself we're subtracting here. And when we do this subtraction, we have 7 minus 4 is 3. And our denominator stays the same, 14. So we can't reduce 3/14, and so that's our answer, 3/14. So if I took my 3/14 and put it back in this equation where x is, 3/14 plus 2/7 would equal 1/2. Alrighty, another example here. We've got an example now with mixed numbers, but we're still going to be subtracting because we've got m plus 3 and 5/11 equals 7 and 2/3. So we want to subtract 3 and 5/11 so that we isolate this variable. We know that if we've added and subtracted the same number, we're at 0, we've canceled them out, and now we're looking for then what does m equal. All right, do our work over here. For 11 and 3, I can list the multiples of 11 until I find one that 3 divides into also, and I'll go all the way to 33 to get that. I have to multiply 11 times 3 to get 33, so I multiply the numerator times 3 to get 15. I had to multiply 3 times 11 to get 33, so I multiply 2 times 11 to get 22. I'm going to do my subtraction now, so 22 minus 15 is 7. My denominator stays the same, and 7 minus 3 is 4. So 4 and 7 33rds is my answer. I can't reduce 7/33, so I'm good. So now what I'm saying is if I put 4 and 7/33 in here and added 3 and 5/11, I would get an answer of 7 2/3. All right, now we've got some subtraction equations. And so our subtractions equations, again, we're going to isolate the variable by doing inverse operations. And so right here, instead of subtracting now, we'll be adding. So solve by adding. Alrighty, so I've got y minus 7/8 equals 5 3/4. I'm going to add 7/8 to both sides. These two are eliminated, and I'm left with y. And now I just need to figure out what this sum is over here. So I'm going to use 8 as my common denominator because 4 times 2 is 8. It's always convenient if you can use one of the denominators that you have. Multiply 4 by 2 to be 8, so 3 by 2 is 6. And then the nice thing is we don't have to change 7/8 at all because we already had the 8 as a denominator. If we don't change the denominator, we don't change the numerator. This is an addition problem. So we know 6 plus 7 is 13. Denominator stays the same. And 5 plus 0 is 5. Now we've got to change this mixed number into an improper fraction. I'm sorry, we have to change this improper fraction into a mixed number. Getting ahead of myself there. So 8 divides into 13 once, with 5 left over. So it divides in once. The leftovers is 5, and that's the new numerator. The leftover part is 5. And we add the 5 and the 1, the whole numbers, and so our answer is 6 and 5/8. Alrighty, over here we've got t minus 2½ equals 1 4/9. So we're going to add 2½ to both sides. And again, this is canceled. We're trying to isolate t. Over here we were trying to isolate y. I'm going to look for a common denominator. I'm listing the multiples of 9 until I find one that 2 will divide into. 9 won't work. 9 times 2 is 18. 18 will work. So 9 times 2 is 18. 4 times 2 is 8. 2 times 9 is 18. 1 times 9 is 9. 8 and 9 will give us 17 over 18. 2 and 1 is 3, so 3 and 17/18. Alrighty, so those are our equations. Now we're going to look at an order of operations problem. Now, so far, the only thing we've learned is to add and subtract fractions. So our order of operations here is going to be pretty simple, really. We don't have any parentheses. We don't have any exponents. We don't have any multiplying or dividing. So we're just going to be dealing with adding and subtracting here. And remember that we do multiplying and dividing in order from left to right, and the same thing with adding and subtracting in order from left to right. So we're going to subtract first, and then the difference of these two is going to be added to this, and then we're going to subtract that last one from that. So we can do this, we can kind of get our common denominators all at once. So if we look at 6 and thirds and fourths and halves, a great common denominator for all of these would be 12. So we could do them all in one step. I think I'll do them piece by piece though. So my first problem is going to be to take 4 and 5/6 and subtract 2/3. So 4 and 5/6 minus 2/3. I'm going to change that to 4 and 5/6 minus, and use 6 as my common denominator because 3 divides into 6 evenly, times 2 times 2, 4, 6. So for this first one, this first problem right here, my answer is going to be 4 and 1/6. 4 minus 0 is 4, 5 minus 4 is 1. Now I'm going to take my 4 and 1/6 and I'm going to add my 2 and 1/4. So 4 and 1/6 plus 2 and 1/4. A great common denominator for 6 and 4 is 12. So this will be 4, and we had to multiply 6 by 2 to get 12. So we multiply its numerator by 2. We have to multiply 4 by 3 to get 12. So we multiply its numerator by 3. And when I add these two then, so I'm adding the sum of these, the difference of these two to this one, and I get 6 and 5/12. So I've taken care of this problem now. Now I'm ready to do this one. I need to subtract 2½. Alright, well I'm going to use 12ths again as my common denominator. So I've got 6 and 5/12, don't have to change that one at all, minus 2, and we've got to change that to 12ths. So we multiply the denominator by 6, multiply the numerator by 6. And so now we've got a problem because we can't take 6 away from 5. So we have to regroup, make this a 5, and we add
Lauren Hobby, Abigail Johnson to the office.
Sorry about that. All right, now we add 5 plus 12. We add the value of the denominator to the numerator, and we get 17 here. So now it's 6 from 17, which gives us 11 over 12, and 2 from 5, which gives us 3. So our answer here should be 3 and 11/12. And that's a lot of work to get to that, but we got there. All right, I'm going to stop this video now and give you a second to kind of think about these, and then I want you to watch the next video about some more applications of fractions.